Released in November 2024, the Model Context Protocol, better known as MCP, took the AI world by storm. Spearheaded by Anthropic, this open standard protocol was unveiled on November 25th and quickly became the go to USB C port for AI systems. But what is MCP? According to Anthropic, the MCP is an open standard that enables developers to build secure two-way connections between their data sources and AI powered tools. In simple terms, suppose your AI application wanted to talk to different components like Web API for search, database for retrieval, GitHub for code related stuff. For this scenario, we would have to write individual interfaces for each services used by our AI application. MCP provides us a way that we can connect to these services easily using a single interface. Let's dig a little deeper. Firstly, we need to understand why MCP was created. Before MCP, connecting AI models to external tools and data sources was a total mess. If you had 3 AI applications and 3 external tools, you might end up writing 9 different integration modules because there was no common standard. This does not scale. This created what's known as a M cross N integration nightmare. If you had M AI applications and N different tools or data sources, you might end up writing M cross N separate custom integrations, which is a maintenance nightmare. MCP tackles this by introducing a standard interface in the middle. Instead of M cross N direct integration, we get M plus N implementations. Each of the MAI application implements the MCP client side once, and each of the N tools implements the MCP server once. Sounds easy, right? Now let's look at the architecture of MCP. The architecture basically consists of 3 components: host, client, and server. The host is a user facing AI application, the environment where the AI model lives and interacts with the user, like cloud desktop or IDEs, that initiates connection to the available MCP servers when the system needs them. The client maintains one cross one connections with server instead of the host application. The MCP client is a component within the host that handles the low level communication with an MCP server. The MCP server is an external program or service that actually provides the capabilities to the application. An MCP server can be thought of as a wrapper around some functionality, which exposes a set of actions or resources in a standardized way so that any MCP client can invoke them. So we worked out what MCP is, but what things we can use in MCP is still not discussed. There are 3 core capabilities MCP server can take care of. Number 1, tools. Tools are what they sound like, functions that do something on behalf of the AI model. Number 2, resources. These are like databases or knowledge bases that the AI can query to get information but not modify. Lastly, prompts. They are predefined prompt, templates, or conversation flows that can be injected to guide the AI's behavior. Okay, too much theory. It's now time to get our hands dirty with coding. We will be creating a local MCP server where our local AI model will be able to talk to the database using 2 tools. First tool will insert records into DB and another will retrieve records from DB. For host, we will be using Olama, which will host our local AI model. I will be running Llama 3 in Olama as it is small and supports tool usage. First step is to create a host for an AI application. For that, install Olama from their website and install Llama 3 tool usage model. This model is small in size and support tool usage. Next step is server. Our server will host 2 tools for our example: DB records reading tool and DB insert command tool. We will use MCP package to create the server. To install it, just run pip install MCP. The database manager class creates a dummy database using SQLite 3 when we start the server. It creates an employee table with employee ID, name, age, job title, and columns. Feel free to change it according to your scenario. Insert employee record is our first tool. This tool is used to insert records into the database. Next tool is to retrieve database records. This will return all records from the DB. So our server is ready now. If you want more tools, feel free to add according to your scenario. Lastly, we start the server. To start, just run server.py file and our MCP server is live. To connect to this server, we need a client. We first create a connection with Olama. Then we define system prompts specifying what our LLM will do. Then we define an agent which can talk to all tools present on the server. Next, we define a function which invokes the agent with user input. Lastly, we initiate the client with agent and start the client server up. Now, when we send a user request through client to retrieve DB values, the LLM calls the corresponding tool. This tool returns the DB values, which is then processed by LLM and shown in a clean way. In this way, we have successfully created a MCP server hosted locally. The complete code is present on the GitHub link below. Feel free to download and experiment with it. If you want more detailed coding examples on your scenario, please let me know in the comments. If you enjoyed the video, please do like and subscribe, which will help me create more videos. See you in the next one.